10 minutes math. This is Edexcel Mechanics M1 WME0101 June 2018. Let us start the first question. The particle B has a mass 3m. So we have here particle B. We have particle B as 3m in mass, and the particle Q has mass equal to m. The particles are moved toward each other, so this is the direction of motion of the B and direction of motion of Q in opposite direction along the same straight line on a smooth horizontal plane. The particles collide directly immediately before the collusion. The speed of V is u, so here the speed is u, and the speed of Q is 3u. In the collusion, the magnitude of the impulse by Q on B, so IB is equal to 5mu. Find the speed of V immediately after collusion, so we need V. We have, let us start to answer this part. IB is equal to m VB minus UB. I will take the positive direction is this direction, so this direction is positive. So IB is 5mu equal to the mass of the V is 3m. VB, I don't know, UB is negative u because opposite of this direction, so minus u. So this m goes this m, so 5/3 u is equal to VB plus u. So VB, which is the velocity of V after collusion, is equal to 5/3 u minus u. So it's equal to 2/3 u. So VB is equal to 2/3 u, and in this direction, right, because it's positive. Okay. Now find the speed of Q immediately after collusion. To find the speed of Q, the equation of motion said that m b u b plus m q u q is equal to m v v b plus m q v q. Now I'll take this direction, the positive direction. So mb is 3m. UB in the positive direction, UB is u in the right direction, so multiply by here u plus mq is m. Now uq is at the negative direction, so minus 3u equal to mv again is 3m. VB from the equation, this is the positive of 3 VB, so VB now will be negative, so minus 2/3 u plus 3m, which mq is m, and vq we don't know. Let us divide it by m, so all the m will go, and here we have this part to go with this part, so now, and the 3 will go with this 3, and all the m will go together, so 0 will equal to minus 2u plus vq. So vq will equal to 2u, and this is a positive. So this is the answer of the second question. Let us go to the other question here. An uniform wooden AB has mass 20 kilograms, so this bar has mass here 20 g, and the distance here 2 meters and here 2 meters. The length of more meter rests equilibrium in a horizontal position on two supports. One support at C, where AC is 1.6 meter, and the other support is at D, where dB is 0.4. A buoy of mass 60 kilogram. So I have a mass here. This is 60 g. Stand on the beam at point B, where AB is equal to 3 meters. This distance is 3. Show in figure 1, the beam remains in equilibrium in the horizontal position. By modeling the buoy as a particle and the beam as a uniform rod, find in term of G, the magnitude of the force exerted on the beam by support C. So we need the reaction here, RC. We're looking for the reaction here, RC. If this is 3 meters and the total is 4, so the remaining here 1 meter. If this is 1 and this is 0.4, so the remaining here is 0.6. This is 0.6 and this one will be 4. So let us find this distance. 4 minus from here to here is 1 minus 1.6. So the remaining will be 1.4. So this dimension 1.4. To find RC, we take the moment at point D equal to 0. And I will take this direction as a positive. So now RC multiplied by 2 equal to 20g multiplied by 2 minus 0.4 plus 60 multiplied by 60g multiplied by 0.6. So let us write this equation. So I have I summation of moment at D equal to 0. So RC, and this is the positive direction. RC multiplied by the distance here 1.4 plus 1.6 is equal to 2 minus 20g multiplied by 2 minus 0.4. So because here from here to here is 2 minus 0.4, 1.6. So 2 minus 0.4 minus 60 g multiplied by the distance now we calculate, which is 0.6. All of that is equal to 0. So RC multiplied by 2 minus 20g multiplied by 1.6 minus 60g multiplied by 0.6 is equal to 0. So RC was equal to, let us find the solution, 20 multiplied by 1.6 plus 60 multiplied by 0.6 equal to divided by 2. So RC is 34g. And this is the value that you need. Okay. Find find in terms of G the magnitude of the force exerted on the beam by the support at D. So he needs the reaction at D. So let us start to solve this part. A sigma f of y is equal to 0. So let's assume the positive is up. So I have RC plus RD minus 20G minus 60G is equal to 0. So now 34G plus RD minus 80G is equal to 0. So RD is equal to 80 minus 34G. So RD is equal to, let us start to find the solution, 80 minus 34. So 46G. And this is RD. Okay, let us go ahead. The boy now starts to walk slowly along the beam toward the point, the end A. Find the greatest distance he can walk from B without the beam tilting. So now the new location, let us draw the new location of the boy. The boy will move until he reaches here. Okay. Now we need the maximum distance from B. So we need, let us find the distance first from C. Let us assume this distance x because we don't know this x. To avoid the tilting of before the tilting of the beam. So when beam tilting, RD is equal to 0. Okay, so let us find now here, this will be the new location 60G with distance x. Let us take the moment at C equal to 0. So 60G multiplied by x will equal to 20G multiplied by the small distance here, which is 2 minus 1.6. 2 minus 1.6. So let us now, for part B, summation of MC equal to 0. So 60G multiplied by x is equal to 20G multiplied by 2 minus 1.6. So x is equal to this part with this part. So 20 multiplied by 0.4 divided by 60. So x is equal to 20 multiplied by 0.4 divided by 60. So 2 over 15. So x is equal to 2 over 15. So distance from B is equal to, from B we have the distance here 1.4 plus x. So 1.4 plus 2 over 15. So it is equal to, let us find the solution, this distance plus 1.4, 1.53, 1.53 meter, and this is the distance the boy can walk without tilting the beam. Let us go ahead. Now a cyclist starts from rest at point O. So he starts here, this is O. On the straight horizontal road, the cyclist moves along the road with a constant acceleration. So he go here with a constant acceleration, 2 meters per second squared for 4 seconds. So T here 4 seconds. and we have v, we can calculate v. Okay, now and then continue to move along the road with constant speed, so he goes straight. At the instant the cyclist stopped, accelerated. The motorcyclist start from rest at the point Q and move along the road with constant acceleration 4 meters per second squared. So one of the motorcycles start here with constant acceleration 4 meters per square. In the same direction of the cyclist, the motorcycle has been moved 40 seconds. So when she overtakes the cyclist, so we go up here. This one is 4 plus t. Sketch on the same axis speed time graph for the motion of the cyclist and the speed time graph for the motion of the motorcyclist to the time when motorcyclist overtakes the cyclist. So we need to find v. So let us solve this question before we start to draw. So we have a of the cyclist equal to 2 meters per second squared, and the time is equal to 4 seconds. So a is equal v divided by t. So from here v is equal to 4 multiplied by 2 is equal to 8 meters per second. Now I can start to draw the same graph that I draw here. Let us draw this graph. So this is the graph, this is 0, and they start to move constant acceleration and then constant speed the cyclist, and then for the motorcycles to start from here and go up with constant acceleration equal to 4 meters per second squared, and then until he reach t plus 4. Okay, let us find the second part of the question. Find the given answer, one decimal place, the time or the value of t. To find d, we can make equivalent distance. Here at t plus 4, both the cyclist and the motorcyclist move the same distance. So the distance of the cyclist would equal to this triangle plus this rectangle. For the distance of the motorcycle, it will be this triangle. We now need to find this v, this value. So we have acceleration equal to v divided by t. Now acceleration is 4 equal to v divided by the total t. So v is equal to 4t. So this value here is equal to 4t. So the first, to answer the question now, be the triangle which is half multiplied by this part here which is t multiplied by 4t, the height, and this is the distance done by the motorcycle, is equal to, for the cyclist we have the triangle which is half multiplied by 4 multiplied by 8 plus rectangle which is this distance t multiplied by 8, t multiplied by 8. Okay, let us start to solve the question. So now we have this part with this part is equal to 2t squared is equal to 16 plus 8t. So 2t squared minus 8t minus 16 is equal to 0. So t squared minus 4t minus 8 is equal to 0. So let us find the t now. Let us go to our, let us start T. This is our calculator. 5, 3, 1 equal, minus 4 equal, minus 8 equal. So 2 plus 2, 2 plus 2 square root of 3. This is T. You need to 1 decimal place. So the value of T for 1 decimal place. So let us now make 2 plus 2 square root of 3. So time will equal to 5.5. So time will equal to 5.5 seconds. And this is the answer you need. Okay, let's start this question. Our plane is inclined at angle alpha. So this is the inclined plane, and this is the angle alpha. So tan alpha 3/4. So this is alpha, this is 3, this is 4, this is 5. So sine alpha is equal 3/5. Cosine alpha is equal to 4/5. Now, a particle of mass 2 kg is projected with speed 6 meters per second from a point O on the plane. So if this is point O, so I have here certain particle. The mass of this particle is 2 kg. So I have here vertical force 2g, and the acceleration in this part, a speed, is equal to 6 meters per second. This is a speed. Okay. On the plane, up a line of greatest slope of the plane. The coefficient of friction between the particle and the plane, we have mu equal to 0.25. Find the magnitude of friction force acting on the particle it's move up the plane. So now let us start to add the forces. We have, if the motion is up, so the friction will be here. So this is the friction force. Now this is 2g. We have here vertically the resistance R. And beside these two forces, the acceleration itself is up. The acceleration is up. And the 2g, this force, I can start now to add one of the force in this direction. And this force will be 2g, this is alpha. So 2g cosine alpha, this is the first component, and the second component will be here, which is equal to 2g sine alpha. This is all the force over the particle. The first question, he asked about the friction. Friction was equal to mu multiplied by r. And r is equal to, from here, r is equal to 2g cosine alpha. So it will equal to 2g cosine alpha, which is equal to 4/5. So which is equal now to 8/5g. So the friction force F is equal to mu 0.25 multiplied by 8/5g. So the friction force is equal to 0.25 multiplied by 8 divided by 5. So it is equal to the friction force F is equal to 2 over 5G, which is equal to by 9.8. So it will equal to 3.92. 3.92 Newton. And this is the first part for the first question. Okay. Particle comes to an instantaneous rest at point A. Find the distance OA. So now this particle is moved until reach A. At A, the speed is equal to 0. The speed is equal to 0. Okay. Let us start to solve this question. So this is B. Now the equation of the motion minus F minus 2G sine alpha is equal to MA. So minus F minus 2G sine alpha is equal to MA. So let us start to write this equation. Minus F minus 2G sine alpha is equal to MA. Minus F is equal to 2 over 5G. So 2 over 5G minus 2G multiplied by sine alpha. Sine alpha 3 over 5. 3 over 5. So 3 over 5 equal to, mass is equal to 2 multiplied by 8. So now I have minus 2 over 5G minus 6 over 5G is equal to 2A. So minus 8 over 5G is equal to 2A. So from here acceleration is equal to minus 4 over 5G. This is acceleration. Now he needs the distance. As you know, we have the relation between the final speed V2 is equal to the initial speed, which is U2 plus 2AS. V2 is equal to 0, so it will be at rest at A. U square here is the initial, which is 6 meters per second. So it will be here U squared 6 squared plus 2 multiplied by minus 4 over 5 G multiplied by S, which is the distance. So minus 36 is equal to minus 8 divided by 5G multiplied by S. This minus will go with this minus, so the distance is equal to, so S will equal to 36 multiplied by 5 divided by 8 multiplied by G. So let us start to find the solution. 36 by 5 divided by 8 divided by 9.81. So the answer 2.3. So this here 2.9 meters. So S is equal to 2.3 meters. So the distance OA is equal to 2.3 meters. Let us find another part. Find the speed of V as it's pass through O. So now it's reverse the motion. The particle now move down the plane from A. Find the speed of B. So to solve this question, we need to redraw. So see here now, this is the particle. Now he start to go down here. so the motion will be down. So the friction will be in opposite direction, so the friction force will be here. So this is the friction, and we have the same forces, which is 2g sine alpha here. So now it will be of the motion 2g sine alpha minus f will equal to ma. So 2g sine alpha is 3/5 minus f is equal to, we find the f before the friction force, 2/5g. So minus 2/5g is equal to 2a. So 6/5g minus 2/5g is equal to 2a. So 4/5g is equal to 2a. So from here, a is equal to 2/5g. Now the same equation again, v squared is equal to u squared plus 2as plus 2as. Now v, I don't know v, and u is equal to 0 because we start in rest, plus 2 multiplied by 2/5g multiplied by s is equal to 2.3. is equal to 2.3. So 2.3. So v will equal to 2 by 2 by 9.8 by 2.3 divided by 5 equal square root answer. So v is equal to 4.25 meter per second, and this is the velocity that he needs. Okay, start this question. A particle B is moving in a straight line with constant velocity at 9 a.m. The position of the vector B, so B, we have particle B, and the position 7i plus 5j, and at 7.2 the position of vector B is, so this one, at 9 a.m. and then the position is equal to 6i or at time 9:20 a.m. So after 20 minutes, so t is equal 20 minutes is equal 20/60 is equal to 1/3 hours. Okay, at time t hours after 9 a.m. the position of the vector B is RB. So at time t hour the position will be RB. Now the first question, find in kilometer per hour the speed of B. So you need the velocity of V. So number A. Now the position of B, RB, is equal to 7i plus 5j plus V multiplied by T. So RB, which is equal to 6i, will equal to 7i plus 5j plus V. I don't know V, but I know the time, which is 1/3. So now 6i minus 7i plus 5j is equal to V multiplied by 1/3. So minus I minus 5j is equal to V multiplied by 1 over 3. So V now is equal to minus 3I minus 15j. And this is the vector of the velocity. Now the speed was equal to, so speed is equal to square root of 3 squared plus minus, of course, 3 squared minus 15 squared. Or it is equal to square root of 9 plus 15 squared will equal to 3 square root of 26. 3 square root of 26, so it is speed is equal to, as a value, 15.3. 15.3 and you need this value kilometer per hour, and this is, yes, kilometer per hour, so kilometer per hour. This is the value that you need. Let us go and read another question. Find the value of t here. Show that RB is equal to 7 minus 3ti plus 5 minus 15tj. So let us now find let us start this question. RB is equal to, now the position of the point is 7i plus 5j. So 7i plus 5j plus v, we find v from here, minus 3i minus 3i minus 15j multiplied by t. So we can write now RB is equal to 7 minus 3t multiplied by I plus 5 minus 15t multiplied by g. And this is the equation that you need. Okay, let us now go to another question. Find the value of t when RB is parallel to 16i plus 5j. 16i plus 5j. So we need the value of t. So let us write this question. Now this is RB. It will be parallel to 16i plus 5j. So 7 to be parallel, 7 minus 3t divided by 16 will equal to 5 minus 15t divided by 5. So we take this value divided this value, take this value divided by this value. Let us make cross multiplier now, cross multiplier. So 35 minus 15t equal to 5 multiplied by 16 minus 15 multiplied by 16t. So let us bring this value this side. So it will be 15t minus 15 minus 15 plus 15 multiplied by 16. So it will be 225 t equal to 5 multiplied by 16, 5 multiplied by 16 minus 35, 45. So t will equal to Now 45 divided by 225, so 1 over 5, t is equal to 1 over 5 hours, so t is equal to 0.2 hours. Okay, so this is the value of the t, and this is number C. Number D, show that the position vector of another particle q at time t hour after 9 is rq kilometer, where rq is equal to 5 plus 2ti plus minus 3 plus 5tg. Show that b and q will collide and find the position vector of the point of collusion. So let us write this question. So this is part D. Now we have RQ, which is equal to 5 plus 2t in I plus minus 3 plus 5t in J. And we have RP, which is equal to 7 minus 3t, 7 minus 3t in I, plus 5 minus 15t in J, 5 minus 15t in J. Now, if I have a collusion, so 5 plus 2t was equal to 7 minus 3t. And here also the same for J. So let us start for I. So now 5t was equal to 2. So t is equal to 2 over 5. This is the first t. The second equation, minus 3 plus 5t is equal to 5 minus 15t. So minus 8 is equal to minus 20t. So t is equal to 8 over 20 is equal to, divided by 4 equal to 2, divided by 4 equal to 5. So the same value of t, so yes, we have a collusion, and the value of the t at collusion is equal to 2 over 5. So position of the point of collusion, so point of collusion was equal to, take this t at any location. So 7 minus 3 multiplied by 2 over 5 I plus 5 minus 15 multiplied by 2 over 5 G. So it will equal to, let us find this value, 7 minus 3 multiplied by 2 divided by 5, 5.8 I, 5.8 I plus this one here, 6 minus 1 G. So it will equal to 5.8 I minus G. And this is the final answer. Okay. Let us start the second question. A car pulls a trailer along a straight horizontal road using a light and extensible 2 bars. So I have a car here, and I have here trailer, and they are connected together by 2 horizontal rods. The mass of the car is m kilograms, so I have here m kilograms. The mass of the trailer is 600 kilograms, so 600 kilograms. And 2 bars is horizontal and parallel to the direction of the motion. There is a resistance motion of magnitude 200 Newton. So we have resistance 200 Newton acting on the car. So I have here resistance 200 Newton in the car and acting on the car, and resistance motion of magnitude 100. So I have 100 here. So 100 Newton acting on the trailer. The driver of the car spot a hazard ahead. Instantaneously, he reduced the force produced by the engine of the car to 0 and apply the brake of the car. The brakes produce braking force on the cars equal to magnitude 6,500. So I have here also 6,500. The braking force, Newton. And the car and the trailer have constant deceleration magnitude. So we have acceleration. So A is equal to minus 4 meter per second square. So this is A. Now, given that the resistance motion on the car and the trailer unchanged, and that the car comes to rest after traveling 40.5 meters. So the car will travel distance here 40.5 kilometers from the point where the brake were applied, and we have here the resistance to the motion on the car. It's not changed. So I have here I have tension, and I have here tension, and both of them is equal. Okay, both of them is equal, and of course here I have this tension in the two cable, one here, one here. Okay. Now the thrust in the toward where the car is braking. So he need now the T. So A at trailer. Now what we have at the trailer, minus 100 minus T is equal to MA. So we have minus 100 minus T equal to MA. MA, so let us start to write minus 100 minus T is equal to M is equal to 600 multiplied by A is equal to minus 4. So the tension force is equal to, here we have minus, so now the tension force that you need is equal to 600 multiplied by minus 4 plus 100. So it will equal to minus 2,300. So this T will go this one. So T is equal to 2300 Newton. And this is the T, the force in the both cable, and the force on the trailer. Find the value of M at the car. What is the force that we have? We have T minus 200 minus 6500 will equal to MA. So again, T minus 200 minus 6500 is equal to MA. So let us write the equation. B at car. Again, T minus 200 minus 6500 will equal to MA. Now T is equal to 2300 minus 200 minus 6500 is equal to M. I don't know M. Multiplier again minus 4. So let us find now 2300 minus 200 minus 6500 minus 4400. So minus 4400 is equal to minus 4M. So now M, which is the mass of the car, would be 1100 kilogram. Okay, let us go ahead to the another part. The time it takes for the car to stop after the brakes are applied. We know the distance, which is 40.5. Let us go now and write the equation. The equation that we have, S is equal to Vt minus half At squared. So S is 40.5. V is equal to 0. Minus half, acceleration is minus 4 T squared. So 40.5 is equal to this one with this one is equal to 2. So 2 T squared. So T is equal to 40.5 divided by 2 equal square root answer will equal to 4.5 seconds. And this is the time that he needs. Okay, let us go ahead to another question. A washing line A, B, C, D is fixed at the point A and D. So we have a fixation here, A and D. There are two heavy items of clothing hanging on the washing line, the fixed at B and the other fixed at C. The washing line is modeled as a light inextensible string. The item at B modeled as a particle of mass 3 kilograms. I have force here, which is 3G. And at C, modeled as a particle with mass m kilograms. So I have here force mg. The section AB make angle alpha with the horizontal 3 and 4. So this is a triangle of alpha. I have here 3, 4, and this is alpha, and this is 5. So sine alpha is equal to 3 over 5, and cosine alpha is equal to 4 over 5. The section BC horizontal and the section CD make angle beta with the horizontal when beta tan beta 12 divided by 5. So if I like to write beta here, so tan 12 5 and this is 13, so this is beta. So sine beta is equal to 12 divided by 13. Cosine beta is equal to 5 divided by 13. As shown in figure 2, the system is in equilibrium. Find the tension AB. So he needs the tension AB. Let us now add the force. I have here AB tension. So let us divide this force now. So this force will go up here. TAB sine alpha, and we will have a force here. TAB cosine alpha. So let us solve the first question A. TAB. So TAB from here, summation of f of y equal to 0. So TAB sine alpha is equal to 3g. Sine alpha is equal to 3g. Sigma f of y is equal to 0. So TAB multiplied by sine alpha, 3 over 5. 3 over 5. 3 over 5 is equal to 3g. So TAB is equal to 3 multiplied by 5 over 3g will equal to 5g. So TAB is equal to 5g is equal to, let us find the value, 5 multiplied by 9.88, 49. So TB is 49 Newton. And this is the first question that he needs. Second one, find the tension in BC. So he needs the tension here at BC. So he needs the tension here, TBC. Again, sigma f of x equal to 0, so TBC is equal to AB, TAB cosine alpha. So sigma f of x equal to 0, TBC is equal to TAB cosine alpha. So this is B. TBC is equal to TAB cosine alpha. Sigma f of x at B equal to 0. Okay. Now TBC is equal to TAB 5g multiplied by cosine is 4 over 5. So here TBC is equal to 4g is equal to, let us find the value, 4 multiplied by 9.8 will equal to 39.2. 39.2 Newton. This is the tension force TBC. Now find the value of M. Let us go now to the second direction, which is at point C. At point C, we have now tension TDC. This force can be divided here. TDC cosine beta, and can go up here. TDC sine beta. You need M. So we need to find the first TCD. And of course we have here the tension TBC. So sigma f of x equal to 0, TBC was equal to TDC cosine beta. Let us add this equation. So C, T sigma f of x at C equal to 0. So TBC is equal to TDC cosine beta, where cosine beta is equal to cosine beta 5/13. So equal to TDC 5/13, and the TBC is equal to 4G. So TDC is equal to 4 multiplied by 13/5G. And this is the first equation that I need. Now summation of f of y equal to 0. So TCD sine beta is equal to mg. TCD sine, so sigma f of y now equal to 0. So TDC sine beta is equal to mg. TDC, which is equal to 4 multiplied by 13 divided by 5G, multiplied by sine beta 12 divided by 13. 12 divided by 13 will equal to mg. This g will go with this z, this 13 will go with this 13. So the mass m is equal to 4 multiplied by 12 divided by 5. So it will equal to 9.6. So 9.6 kilogram. This is the mass at point C, and this is the last question in this exam. Good luck. Bye.